String representations. In the object-oriented programming metaphor, we say that an object should behave like the kind of data it is meant to represent. And one aspect of that is that an object should know how to present itself to the world as a string, or to produce a string representation of itself. And strings are important. They're descriptions not only in natural languages that the humans use to communicate with each other, but also in programming languages. You can put an expression in a string. So in Python, this distinction is built right into the language. All objects produce two string representations. One is called the str string, and it's designed to be legible to humans. The repr string, by contrast, is designed to be legible to the Python interpreter. That is, it's supposed to be an expression in the Python language. Now, a lot of times, the str and repr string are the same, because Python was designed to be a language that people could read. And so, a lot of the expressions have exactly the same form as a person might write down when they try to communicate the same idea. You write the number 1 in either case. But sometimes these differ. Let's look at an example. First, we'll consider the repr string for an object. There's a built-in function called repr. It returns a Python expression as a string that evaluates to an equal object. If I call help on repr, this is what I see built into the language. Repr can be called on any object it produces a string, and it's supposed to return the canonical string representation of the object. For most object types, the documentation says, calling eval on the repr of the object gives you some object that's equivalent to the original. The result of calling repr on a value is exactly what you see in an interactive session. It's what Python prints out right below the expression you evaluated. So if I evaluate this expression, which represents 12 times 10 to the 12th power, the canonical string representation is 1 and then 2 and then 12 zeros and then a decimal point and then a 0. And that's what gets displayed. Exactly the same thing gets displayed if you call print on the result of calling repr on 12 times 10 to the 12th. Now, some objects do not have a simple Python readable string. There's no way to write down an expression that very easily captures everything that some object is, or an expression for how to create something that's equal to the original object. And this is typically true of compound things, such as functions or classes. The min function that's built in just can't be written in a single expression. So instead what you see when you call repr on min is this proxy, which uses angled brackets to indicate that this is not, in fact, a Python expression at all. It's just some stand-in, a human-readable description, because generating a Python expression just didn't work out. The str string of an object can be different. Human interpretable strings are useful as well, and so we'd like to have our programs be able to generate them, because oftentimes a program wants to communicate something with a user. So here's an example. There's a fractions module, part of the standard library, and it has a fraction class. A fraction is built from a numerator and a denominator. The repr of a fraction is just a call to the class itself, exactly how you'd construct the fraction in the first place. But that's not how humans write fractions. Humans write fractions like that. So str is a built-in function that takes any object, gives you back a string, where the string is some human interpretable representation of the original object. The result of calling str on the value of an expression is what Python prints out when you actually call the print function. So if I print half, I'll see 1 divided by 2. Now notice this has quotes around it because this is a string. whereas this is just what happens when you print the string, the contents of the string. All right, let's try it out. From fractions, import fraction gives me access to this class, which I can bind an instance of to the name half. Now half is a fraction. The repr string of half is just that. If I print half, I see 1 divided by 2. The stir string of half is 1 divided by 2. Now, if I evaluate the repr string of half, I get the fraction. It's a different object, but it's equivalent, right? If I evaluate the stir string of half in this case, it turns out that is a valid Python expression, but that's just kind of coincidence. What you get back is not a fraction, it's a float. 1 divided by 2 is really just there to be interpretable by humans. We can learn a little bit more about the repr and stir functions just by trying them out on strings. So here's a string, hello world. What happens when I evaluate s? I see that string. That's what happens when I print out the repr of s. Same thing. Now what happens if I print out s? The quotes go away, which is exactly what I see when I get the stir of s, because the stir of s is just s. Now what happens if I just call repr of s? I see quotes within quotes. What's going on there? Well, what repr is giving me is a string, where if I evaluated it, I'd get back the original string. And what if I called the repr of the repr of the repr of s? I'd get a mess. What's going on there? Well, this is not just quotes within quotes, but quotes within quotes within quotes within quotes. And Python has to use backslashes in order to indicate what quotes really end a string and what don't. The details of that are not important. What is important is that if I evaluate the result of evaluating the result of evaluating the repr of the repr of the repr of s, I get back s. Now what if I had just evaluated s in the first place? I'd get an error. Hello, world is not a valid Python expression. When I have quotes around it, it is. So if I evaluate the repr of s, everything's fine. But I can't evaluate s, or the stir of s, because what I have here is not valid Python.